Welcome back to G Fun Facts Online, where we dive deep into the coolest, weirdest, and most mind-blowing science facts. Today, we're heading to one of the most extreme places on Earth, Antarctica. Now, when you picture Antarctica, you probably imagine a vast, frozen wasteland, static and unchanging, right? Well, what if I told you that beneath that icy calm, there are dramatic heists happening on a colossal scale? We're talking about a phenomenon called ice piracy, where one glacier literally steals ice from its neighbor. It sounds like something out of a polar adventure movie, but it's very real, and it's reshaping our understanding of the frozen continent. So what exactly is ice piracy? Imagine two rivers of ice, glaciers, flowing side by side towards the sea. Now picture one of them starting to flow faster, thinning out, and in the process, it starts to divert or capture ice that would have normally flowed down its slower neighbor. It's like a river changing its course to steal water from another, but this time, it's happening with billions of tons of ice. Recent research, especially in West Antarctica, has shown that this icy theft can happen much faster than scientists ever thought possible. Not over centuries or millennia, but within mere decades. Let's zoom in on a specific crime scene, the region of the Pope, Smith, and Kohler Glaciers, or PSK for short, in West Antarctica. Researchers from the University of Leeds and the British Antarctic Survey have been keeping a close eye on this area, using high-resolution satellite images and analyzing glacier crevasses. Between 2005 and 2022, they tracked how these massive ice streams were moving, and the results were startling. 7 out of the 8 major ice streams in this region had sped up, flowing towards the sea an average of 51% faster than in 2005. Their average speed at the grounding line, that's where the glacier meets the Amundsen Sea and starts to float, was about 700 meters per year. Some glaciers, like Kohler East, accelerated by a whopping 60 to 85%, and Smith West even hit an 87% speed increase, meaning it's now flowing almost twice as fast as it did in 2005. But here's the twist. While its neighbors were racing ahead, the Kohler West Glacier actually slowed down by 10% during the same period. Why? You guessed it, ice piracy. The faster-flowing, thinning Kohler East Glacier started to siphon off ice from its slower neighbor, Kohler West. This rerouted Kohler West's ice flow, causing it to slow down, while Kohler East got an extra boost from the stolen ice and sped up even more. What really blew the scientists' minds was the sheer speed of this whole operation. Previously, it was believed that such diversions of glacier flow were incredibly slow processes, taking hundreds, if not thousands, of years. But the satellite data from the PSK region painted a very different picture. This particular act of ice piracy took place in less than 18 years. This is a groundbreaking discovery because it shows just how dynamic and rapidly changing these massive ice sheets can be. So what's driving these accelerated ice movements and this frosty felony? The main suspect, as you might expect, is climate change. Rising sea temperatures and changing ocean currents, especially in West Antarctica, are causing the ice to melt faster, particularly at the grounding line, that crucial zone where the land-based ice transitions into the ocean and begins to float. When this grounding zone melts from underneath due to warmer ocean water, the glacier loses its footing and can flow much faster. This melt and slide effect then ripples further inland. In the case of our Kohler glaciers, researchers suspect that faster melting at Kohler East's grounding line caused it to pick up speed and thin out. This thinning then allowed it to literally absorb ice from its neighboring, slower Kohler West Glacier. This diversion of one glacier's flow into another is a direct consequence of these changing conditions at the glacier's base. Now, the idea of piracy isn't entirely new in Earth sciences. We've known for a long time that rivers can capture water from each other by one river expanding its drainage basin at the expense of another. Scientists had suspected that glaciers might behave similarly, but observing such a process happening over such short timescales is a completely new ballgame, made possible only by modern satellite technology. This discovery of rapid ice piracy has significant implications for how we understand the stability of the Antarctic ice sheet. When ice streams are rerouted, it affects the thickness and stability of the ice shelves further downstream. Ice shelves are those massive floating extensions of land-based glaciers, and they play a crucial role. Think of them like a cork in a bottle, holding back the land-based glaciers and slowing their flow into the sea. If these ice shelves become unstable due to changing ice inflow or warmer waters, it can lead to an accelerated loss of ice from the glaciers behind them. The glaciers in West Antarctica alone, including Pine Island, Thwaites, Haines, Pope, Smith, and Kohler, hold enough ice to raise global sea levels by about 1.2 meters, or nearly 4 feet. The ice piracy we're seeing is another mechanism that can contribute to this instability. For instance, in the PSK region, the Dotson and Crossan ice shelves receive ice from the Kohler glaciers. This piracy could potentially stabilize the Dotson ice shelf by feeding it more ice, but it might also speed up the decay of the Crossan ice shelf. And these aren't isolated incidents. The entire Antarctic continent is responding to global climate change, with the Antarctic Peninsula and West Antarctica warming particularly rapidly. The loss of inland ice, especially in West Antarctica, is substantial, and calving glaciers are dumping huge amounts of fresh water and sediment into the ocean. The instability of glaciers like Thwaites, often dubbed the Doomsday Glacier, is another worrying sign of the West Antarctic ice sheet's fragility. These new insights into ice piracy are vital for improving our climate models and our forecasts for sea level rise. The more detail scientists can get on these dynamic processes within the ice sheets, the more accurately they can predict future changes. This is absolutely essential for developing strategies to adapt to climate change and for making informed policy decisions. This research highlights that the interactions between land-based ice sheets and sea ice are critical factors for Antarctic ice development, even in the short term, an aspect that might have been underestimated before. So the discovery of rapid ice piracy hammers home the point that Antarctica is not some static, eternally frozen landscape. It's an incredibly dynamic system that reacts sensitively to change. Phenomena like glaciers stealing ice from each other are crucial pieces in the complex puzzle of a changing continent. Continuous monitoring using satellites, combined with field studies and advanced modeling, will be key to unlocking the secrets of this icy realm and better assessing the consequences of climate change for all of us. The ice pirates of Antarctica have taught us a vital lesson. The changes happening at the South Pole might be occurring faster and in more complex ways than we ever imagined. Thanks for tuning into Fun Facts Online. Join us next time for more fascinating science.